voltage of 115 measured between a phase and earth, or 200 volts measured between phases. When specifying a three-phase AC power supply, usually both voltages are referred to. On the aircraft, only phase to earth voltage can be measured, which should read 115 volts, as you can see on the voltmeter here, which is selected to indicate external AC power voltage. The quality of the external power is checked by the ground power monitor unit when it is plugged in at the external power socket. A green light at the external power panel will show the ground personnel that the power is correctly plugged in, found acceptable, and is now selectable on the flight deck. The green light is repeated on the forward cabin attendant's panel to indicate that AC power can be selected for cabin lighting and servicing. The indication is also shown on the flight deck at the electrics overhead panel. Although the green light will be lit as long as the external power remains within certain specifications, you still have to check the voltage and frequency before selection. The AC busbar system uses 5 contactors to control the power supply to the AC buses 1 and 2. On the following pages, we go through the automatic operation of the AC busbar contactor system. For that, the bus tie AC switch must be set to auto at the electrics overhead panel. Should this switch be set to open, automatic transfer of a power source to a non-dedicated channel is inhibited. As a preference, the contactor system will automatically try to connect the engine-driven generators to the bus bars. If only the engine generators are available, the contactor system will arm the opposite generator as a reserve for the other channel should a failure occur. If a generator fails, the contactor system will then automatically select the remaining generator to power both channels. Should an external AC supply or the APU generator be available, the contactor system will automatically select that source as a reserve power supply. In case of a generator failure, the APU generator or the external AC supply will be automatically used to power the channel of the failed generator. The transformer rectifier units, TRUs, convert 115 volts three-phase AC power to 28 volts DC power. The TRUs are connected to the AC buses 1 and 2 by remotely controlled circuit breakers on the flight deck overhead panel. The TRUs and DC bus bars are connected by automatic cutout switches, ACOs, which close when the DC power supply from the TRUs is satisfactory. Another DC power source are the 24-volt aircraft batteries. The batteries are connected to the emergency DC bus by manually switched battery contactors. Additionally, battery number 1 has a permanent connection to the hot battery bus bar. This bus bar continuously supplies vital services at relatively low currents. Battery voltage must be at least 23 volts before selecting aircraft power on and thus charging the batteries. A lower voltage could result in an overcharging of the batteries as no limiting device is fitted. Battery charging is done by powering the DC bus bars from the TRUs. As you already know, the DC bus bars are at 28 volts, thus the batteries are floated during charging. Charging is indicated by the battery voltage going up to 28 volts and the amp meter indicating a charge current. If the batteries are overcharged, they heat up and could explode. This is prevented by an automatic disconnection of the respective battery at a certain temperature limit. On the Avro RJ, we have two different sources of standby power which are needed when the primary supplies have failed. The first one is the standby generator, which supplies 115 volts three-phase AC power at a constant frequency of 400 Hz and via an internal TRU 28 volts DC power. The hydraulic standby generator is driven by the green hydraulic system. However, it needs the full system pressure of 3,100 psi to generate the correct output. That means, in turn, it cannot be powered via the PTU. To ensure that this pressure is available, the other services will be isolated. This isolation is indicated on the overhead hydraulic panel by an amber low press warning. The full system pressure is still displayed on the analog gauge. The standby generator supplies the essential AC and DC bus bars and, in turn, the emergency AC and DC bus bars. The standby generator has its own generator control unit, GCU, which monitors output voltage and frequency. Should these values be in limits, the standby generator's AC and DC output will be connected to the essential AC and DC bus bars. If a fault is detected, the standby generator supply will be disconnected from the busbar system. The other standby power source is the standby inverter. It will be ready to supply the emergency AC bus bar if the standby generator fails. The emergency DC bus will be supplied by the batteries. The standby inverter is a solid-state device. That means it does not need cooling or lubrication, as no mechanical parts are involved. It inverts battery DC power to 115 volts single-phase AC power at a constant frequency of 400 Hz, which is supplied to the emergency AC bus. When two batteries are fitted, power to the emergency bus bars is available for about 60 minutes. With a single battery, this time span is reduced to about 30 minutes. Battery life will depend upon electrical load, which can be reduced by reference to the abnormal and emergency checklist. Now, please have a look at the limitations of the main engine generator. The APU generator on ground, in the air, and the batteries. Load shedding may be necessary to remain within these limits. If, during flight operations, a system failure is accompanied by tripping of a circuit breaker, one reset attempt may only be made if this is specified in the relevant abnormal and emergency checklist or the system is operationally essential. Now, we will look at the external checks associated with the electrical system. After the following pages, you will be able to carry out these checks and identify problems which require further investigation. Starting at the aircraft nose, check that the external AC power, if connected, is correctly plugged in, or that the external AC panel door is correctly closed. Then move on to the electrical bay door. Open the door and push it inwards until it engages into its mechanical stop. In the bay, look right at the batteries. Confirm that there is no leakage and that they are securely mounted. Check that all underfloor circuit breakers are set. Looking upwards, check that the wheel spin test switch is set to normal and that all equipment in the bay is secured. Having completed the checks within the electrical bay, close and lock the access door by twisting the door handle to a horizontal position. Check that the external DC socket door is securely closed.